I'll now go through the panels, and I'll describe each of the functions and how it works. So this is the master panel, where we obviously create and control the entire flocking setup. As you add new flocking items to the scene, they'll appear in this list here. You can see we've got a flock here, which is the item that generates the agents. It's a box, that's its scene name, and you can change its color just to help navigate your scene. Following that, we have a director, which is a scene item that gives motion and behavior to the agents that are in the scene. So we have a director, its type is a goal, and all the agents will simply try and approach it as close as they can, trying to avoid crashing into each other. Under the add new menu option, generator is simply add a new collection of agents into the scene. So I can add that here. The actual position, it's only the initial position that means anything, so if it's keyframed it won't do anything. So I've added a new one here. It's count 3x3x3, which is 27 agents. So we can make this one a bit different and show you how that all interacts. Currently there's no control for groups, so if there's any directors in the scene, all agents will try to be affected by them. We're looking at changing that for future iterations. So I've added a new flock here. If I go calculate, it's created the agents, and then they'll fly after the director as well, and they'll interact with the, you can see there how they're actually pushing against the other agents that we have in the scene, so everything all interacts together. And if you want, you can simply make a copy of that, zoom out so you can see what's going on, and make another copy, and we can easily add multiple generators to the scene very quickly. And the same goes for directors. So we can add that, and we can clone him, make that do something slightly different. All directors are is just a keyframed null with a director plugin attached. There's no magic there. Calculate. And there the flocks are moving, trying to approach to the closest director. And you can see some really interesting effects, especially here where the range between the two directors is causing some agents to go towards one, some to the other, and then they end up swapping. So by adding quite a few directors to the scene, you can end up with quite complex behaviors. The edit menu here is just for removing items and duplicating them from the list. And over on the right hand side we've got the settings for any of the items you've selected. As you select an item in the list, it will select it in the scene as well, and that reciprocates. If you select a scene item, it will select it in the list. So it's quite simple and easy to keep track of which items are which. You also have the scene name next to the item as well. So these are the properties. All of the flocking items have a user definable color, which can help to set your scene up so it's easily navigable. You can show the trails for the agents, so you can see there is expanding out the number of frames at which it shows the trails over. You can see the lines being drawn out, and that's exactly what will be followed. Just gives a bit of a preview as to the motion of the items. So rather than having to trace through and see where they go, you can just brighten that up. So rather than scrubbing through and seeing where the agents end up, you can just use this trail option to see how the motion of the scene will be affected by changes. So if I go calculate all motions, you can see there how the paths in the scene are being affected. Show ranges turns basically with flocking agents, we specify a minimum range that we want them to interact with. We don't want them to get any closer than that particular range, and when they when they approach that range, we want them to start influencing each other. This is just a quick preview for that. The tabs down here for flocks controls the generator type. So we've got box and sphere at the moment. Box is the number of agents along each axis and the size of each axis. So you can see that as I scale that up and down there, that's the size of the initial frame that they appear in. We can also set that to a sphere if we don't want a regular arrangement, and it will simply randomly scatter that number of agents within that sphere. If you have a mesh item in your scene and you've applied a flocking plugin to it, you can use the points and the polygons of the mesh to generate the agents as well. So you're not limited to only starting out their initial positions via box and sphere. You can actually generate it off of any mesh. The Agents tab gives you the list of basic agent behaviors. We've got a simple preset list here, which can give you a good initial setup. The range, which I told you about before, is the minimum range at which the agents interact. So if I set that to a meter, then when two agents approach closer than a meter, they'll try to avoid colliding with each other and push away until they reach that meter apart, that meter separation. View angle simulates animal vision. Most animals can't see perfectly behind themselves. Most vision's limited to a cone out the front. You can simulate that as well, so agents won't interact with agents that are behind them, for example. At the moment it's set to 180 degrees, which is front to back vision. These next 6 options control the actual motion of the agents themselves. Avoid collisions is a coefficient for how eagerly they try to avoid crashing into each other. Cohesion is a coefficient for how eagerly they try to maintain this distance between themselves, not getting any closer, not getting any further away. Match velocity is a percentage that they will adjust to when two agents approach within this value here. They'll attempt to adjust their velocities so that they're moving in much the same direction. Juggling this value can be quite useful for preventing collisions, because as two agents get closer together, their velocities will end up matching, so rather than colliding, they'll just end up moving in the average direction that either of them was. Acceleration is the rate at which the agents can speed up, slow down and turn around, and the minimum and maximum speeds are fairly self-explanatory. This last option down the bottom, lock to ground and the ground level. If you have a scene where you want agents to move over a terrain, you can use lock to ground and then apply a texture to the ground level, and that will enable these agents to, instead of just floating around in space as they are here, you can actually lock them to a texture. So if you've used a height map to create your terrain, you can use the same height map here and get them locked onto that ground mesh. And the final tab is an option just to provide an initial velocity for the agents. Let's say, for example, if you're simulating missiles and you want them to take off at high speed in a particular direction and then turn around and track an object in the scene, you can apply an initial velocity here to do that. The use normals checkbox is if you're generating agents from a mesh item, you can use normals to define the direction that it's based off the polygon normal to define the direction that they start off. If we select a director here, we get a different set of options. We have the director type. Most of the time you'll probably use goals, deflects and paths. I'll explain what each of these does. A goal type director very simply works like gravity with particle effects. It basically calls all of the agents in the scene towards itself continuously. the range is obviously the range at which it works over. If you set it to 0, then it will work across the entire scene. If it's higher than 0, then only agents that approach within that range will be affected by it. And the weighting is if two goal type directors are overlapping, you can use the weighting to control how eagerly the agents approach one or the other. And again, you can control the color for easy navigation here. An avoid director is the opposite of a goal. As an agent gets closer to an avoid director, it will actually be pushed away from it. So you can use these for helping direct the agents so that they don't crash into scene meshes in the scene. Again, range and weight here are applied the same way as the goal director is. Deflect type director is a little bit different. It's similar to avoid, but it basically just pushes agents sideways instead of pushing directly away from them. By that I mean, if you have a deflect agent, a deflect director in the scene, and an agent is flying directly towards it, the agent will be pushed sideways, so it just skims past the deflector. But if you have an avoid director in the scene, then the agent will be continually pushed away from it, even if it's heading straight towards, so it will exhibit some slowing down. But with a deflector, there's no slowing down. It simply changes its path to miss. Again, you'd use this for making sure that items in your scene don't crash into meshes and things. Path director is a bit trickier, and I'll probably set up a new scene just to demonstrate that. So what we'll do is we'll clear everything out, and I just want to set up a new generator here. Path's one of the more interesting directors that we can apply to. I'll just apply a goal and then I'll turn it into a path afterwards. So I've got a path here. What you do is you keyframe out a motion path, and you can see as I'm keyframing that out, it's producing basically a tunnel behind it, and you can actually adjust the scale of that as well if you want. And what this will do is define a swept volume that the agents will try to maintain their position within. So as they fly through the scene, what they'll try and do is stay inside this shape here that we're defining. So I move that to the start of the path and hit calculate. Then as we scrub through, you can see all the agents are moving along that path. I'll just push that out a bit more and give them some more. Let's have a heap. There you go. So you can see they're clearly moving along that path. It's probably one of the easier ways of directing a series of agents to move through your scene. And you see they're following up and down there nicely. You can use goals to simply pull them through the scene, but using a path is probably a more accurate way of doing it. And it's the method I'd recommend. The final option that we've got here is converge. What converge is used for, it's essentially the opposite of deflect. It will attempt to bunch up a series of agents that are approaching a small gap. So if you're trying to squeeze a heap of, say, bees through the opening of a hive, you would use a converge director to try and squish them down so that they would encroach closer than that minimum value that we have here. Just to get the design, to make them move through a small opening, rather than positioning, say, deflectors on all sides of the opening. We can just put one converge director directly on top of it. The final tab that we have here is the cache. A cache is created when you push the calculate all motions button. avoid having to obviously recalculate the agent positions each time. You can recalculate that each time you load the scene up, or you can use the cache options here to save that out to a file. Now, although you can add new flocking items through the master control panel, you can add them by hand, essentially, if you wish. So if I add a new null here, call it flock item, bring up the custom objects list. You can add flock directors and flock generators from here. And if you double click, you get exactly the same options here. Perhaps you don't need the master panel open. You can just work on a single director at a time. It's flexibility for the user. You can choose how you want to work with the system. And the same goes obviously for directors. You can just add a null and then add a director type to that. There is one plugin which can't be added through the master panel yet. That's the flock item motion plugin. We've done this to enable you to move a scene item through the scene using the flocking controller rather than simply applying instances. So by using a motion controller, you can make, say, lights, for example, move as though they were part of a flock. So if I go calculate here, you can see here now the light follows the path as well. So you could do, for example, a string of lights quite easily. So you just turn them to point lights, and we could make copies of them. And then they can all move through the scene, and they could illuminate as they move along.